You know, it's easy to forget there's some serious magic happening inside our phones every single day. I mean, think about it. It's one thing for your phone to translate words, but how does it even see those words on a messy, real-world sign to begin with? This isn't like an AI recognizing a cat or a car. This is about decoding the abstract, complex symbols that make up human language itself. So how on earth does it work? So here's what we're going to cover in this explainer. We'll start with the basics, putting a name to the technology. Then we'll walk through the actual step-by-step pipeline computers use to read. After that, we'll get into why reading text out in the real world is so hard. We'll even look at the curveballs different languages throw at this tech, and of course, we'll wrap up by looking at what's next. All right, let's kick things off by putting a name to this everyday magic. The whole field is called Optical Character Recognition, or just OCR for short. And what is it really? Well, you can think of it as a translator, but not for languages. It translates a picture, just a bunch of pixels, into text that a computer can actually process and understand. It's the essential bridge between what we see and what a machine can use. And you might not realize it, but OCR is everywhere. Seriously. It's in massive projects digitizing ancient books, it's what sorts your mail, and it's how you can authenticate your ID just by taking a picture. It's the key that lets self-driving cars read road signs. And it's doing incredible things like helping visually impaired people read with apps and wearables. It's even being used to scan grocery receipts to track what you eat. I mean, look at this list. It's woven right into the fabric of our modern world. Okay, so how does a machine actually pull this off? Well, it's not just one magic trick. It's more like an assembly line. A carefully designed pipeline with a few really important stages. Modern OCR really boils down to three main jobs. First, you gotta clean up the image to make it clear. Second, you have to find the text. Where is it in this picture? And third, once you've found it, you have to actually figure out, what does it say? Let's break those down. Okay, step one, pre-processing. This is all about getting the image ready. Imagine trying to read a really blurry, smudged photocopy. It's tough for us, right? Well, it's a nightmare for a computer. So the first thing the AI does is clean it up. It gets rid of random pixel noise, it cranks up the contrast to a stark black and white, that's called binarization, and it smooths out all the jagged edges. Basically, it creates a perfect clean canvas to work from. All right, step two, text detection. Now that the image is clean, the computer has to play detective and find the words. It uses these really smart deep learning models that scan the whole picture and go, aha, that looks like text. Then it draws these little virtual bounding boxes around every word or line it finds. This is super important because it separates the text from, everything else in the background. The trees, the walls, you name it. And that brings us to the grand finale, step three, text recognition. The system takes each one of those little boxes of text and hands it off to an even smarter AI model. We're talking about things like recurrent neural networks, or the big one these days, transformers. And the reason these models are so good at this is because they're masters of understanding sequences. And what is a word if not a sequence of letters? They look at the visual pattern and say, okay, that sequence of shapes is T, H, E. And just like that, pixels become actual readable text. So that pipeline, it sounds pretty straightforward, right? And for a nice, clean, scanned document, it works great. But reading text out in the real world, what the experts call in the wild, oh, that is a completely different beast. One of the absolute biggest headaches is something called irregular text. See, in a book, text is nice and flat and horizontal, but in the wild, no way. It's curved around a coffee cup, it's warped because you took the photo from an angle, sometimes it's even running vertically up a sign. All of this just shatters the simple rules that older OCR systems were built on. And the shape is just the beginning. I mean, think about the photos on your phone. They can be blurry, right? Or low resolution. The text might be plastered on a super busy, cluttered background. Or you've got terrible lighting creating weird shadows and reflections. Every single one of those things makes it insanely hard for the AI to do its job. And you don't have to take my word for it, the numbers tell the story. Look at this. There's a well-known model called Aster. On clean, simple text, it's fantastic, over 93% accurate. but you give it that messy, irregular text from the real world, the accuracy just dives all the way down below 80%. That's a huge drop, and it really shows you what a tough puzzle this is. So how do you even begin to fix this? Well, researchers came up with a really clever trick called text rectification. One of the coolest methods uses something called a thin plate spline transform. Don't worry about the name. Just imagine the AI overlays a flexible digital grid onto the curvy text. Then it uses that grid to digitally pull and stretch the image, basically uncurving the text until it's a nice straight line. It's like digitally ironing it out so the next AI in the pipeline can read it easily. Okay, so we've talked about distorted text and blurry photos. But what if the text itself is the challenge? Because not all languages are written the same way, and that creates a whole new world of problems. Just look at the difference here. In English, our letters are mostly separate little islands. You can pretty much draw a box around each one. But in cursive scripts, like Arabic or Urdu, the letters all flow together. They're connected. So the idea of just cutting them up into individual characters, it doesn't work. It's like trying to separate drops of water in a river. And the complexity goes even deeper. A single letter in Arabic can have up to 4 different shapes depending on where it is in a word. Then you have these tiny little dots and marks called diacritics that can completely change a word's meaning. And the characters themselves often overlap and merge into complex shapes. It's an absolutely monumental challenge for an AI. The big breakthrough came when researchers had a shift in their thinking. They stopped trying to hunt for individual letters. Instead, as this research from 2019 points out, they started seeing words as a sequence of basic shapes and the joiners that link them together. It's a totally different way of looking at the problem, and it turned out to be the key. And wow, did it work. Check out this chart. It's from a study on OCR for the Quran. A standard algorithm really struggles, but an improved algorithm, one built specifically to understand Arabic script, it nails it, with over 96% accuracy on those super tricky little diacritics. It's perfect proof that you can't have a one-size-fits-all solution. You have to respect the structure of the language. Okay, so we've seen how this tech works and the incredible hurdles it has to overcome. So for our final section, let's look to the horizon. Where is this amazing technology going from here? Well, things are moving at lightning speed. We're seeing new end-to-end models that do the detection and recognition all in one go. They're faster and more accurate. Transformers are getting even better at understanding context, so they make fewer simple mistakes. And the applications are getting wilder too. Think augmented reality that helps visually impaired users by reading signs in real time. And get this, new AI techniques like diffusion models are starting to show they can take a blurry, unreadable image of text and make it perfectly sharp. So when you boil it all down, the big takeaway is this. Teaching a machine to read isn't some problem we just solved and checked off a list. It's an ongoing journey. A journey from the perfect, clean pages of a book out into the messy, chaotic, unpredictable real world. Every single blurry photo and curved sign represents a new frontier, a testament to decades of human ingenuity. Which leaves us with one last big question to think about. As this technology gets better and better, as machines learn to read not just every book, but every sign, label, and handwritten note in the world, what should we point their cameras at next? What new understanding will we unlock?